last time we did solve the rigid two-dimensional rotator. So we got its states as function of quantum number. We found that there is quantum number, that the energy grows, and for two-dimensional rotators, each except zero state are double degenerate. If you allow three-dimensional rotation, it will be escalating degeneracy, same as you see in hydrogen atom. I will give a quick comment on how to relate this three-dimensional rotator to vibrational spectra, and then we will do thing from which some advanced classes just start. We will do Bohr model. It is wrong. It is, but it is the only thing that we can do in the given time. It was the most successful model at the beginning of 20th century to get atomic spectra, and the main outcomes, like dependence of energy of states in hydrogen atom, is absolutely correct. But in some sense, Bohr model has same shortcomings as two-dimensional rotator against three-dimensional. There are just circular orbits, which is too simplified. And if things go forward successfully, then at the end of the meeting, we will be able to discuss absorption spectra and emission spectra of hydrogen atom, which not from truly three-dimensional solution of Schrödinger equation, but based on Bohr's model. Okay, start. So, oh, there is no jump. This is just little thing what we do. One would do if there is a three-dimensional rotators. Then the angular momentum is cross product as a determinant of position, momentum, and basis vectors. And then there will be three components of angular momentum. We did only Z, but in true life there are more of those, and each of which is product of position and momentum in different order. And if one deals with three-dimensional angular momentum, it follows some beautiful commutative relations. We may touch it on Friday or next Monday, but it's like a new world that one can spend a semester. So projects today. We did solve two-dimensional rotator, found allowed values of magnetic quantum number by solving this trigonometric equation, found degeneracy and eigen states, which are here on the top. And if one wants to do similar thing for three-dimensional rotator, then degeneracy escalates. If one does know the eigen states, then one always can find energy as a matrix element inside the sandwich. And the benefit of using this finding is that one can predict optical transitions between such states. If you have a diatomic molecule that rotates and may also change its vibrational quantum number, then experimentally it will show the spectra that looks like wings of an eagle. In order to match, understand, interpret, and predict possible experiments, one needs to match the quantum solution and experiment, reproduce energy of each peak and intensity. And there are several factors that one may benefit from the model. So there are quantum states, there is a degeneracy, number of states at each energy, there is energy, and if I divide everything by the same factor, it will be just progressing at the natural numbers because it's scaling factor. And then, so if we are speaking about spectroscopy in general sense as a way to probe material with electromagnetic radiation, then one needs transitions between states. So 2 minus 0 will be 2. 6 minus 2 will be 4. 12 minus 6 will be 6. And these numbers come from the Hill. So in addition, these energies are plugged into the resonance condition that must match the transition energy of the light. Then initial and final state should have different population, and one should also add degeneracy. And there is a thing that corresponds to matrix element of transition, which technically we can compute as a matrix element of dipole. And putting initial and final state, putting interaction operator between them, and take it square because it is probability. And then this combination will give the intensity, and this match will give the position where peaks do appear. So, interestingly, transitions are possible only from states not directly accelerating rotations, but promoting from one oscillation to another oscillation, no oscillations to first excited, and simultaneously changing the quantum number of rotation. Interestingly, the transitions are possible only when the vibrational rotational quantum number changes by 1. This comes from careful evaluation of the matrix element of transition. And one is finding that some transitions are predominantly zeros, and some are depending on the argument, on the number. But these restrictions on the transition intensities are called selection rules. And you may have heard it, or you will hear it in maybe in next PChem or in inorganic chemistry, selection rules. So when one goes with increase of rotational quantum number, the transition energy is bigger than the fundamental transition between these vibrations. If it is smaller, it is lower. And there is a why these wings of eagle are appearing. Because the energy offset between each vibrational level increases here and there, and transitions are possible only between states that are different. And due to increasing energy offset, the transition energy increases as far as we go to higher and higher pair of level. So it gives this offset. Now, the growth originates from the fact that degeneracy of the thermally occupied levels, degeneracy of the vibrational level increases as we go upward. And then the decrease is related to the fact that the higher the level, the smaller thermal occupation. So if it is very high, even at normal temperature, it will be unoccupied. At room temperature, this lowest energy, and their energy offset is smaller than thermal Boltzmann constant times temperature. Therefore, all of these levels are populated and contribute to transition. Make sense? This last 5 minutes was true physical chemistry without theory. And here are just additional details of the offset, degeneracy, Boltzmann distribution that gives this wings. Whew. So, what do we expect to get today? Okay. Move this stripe somewhere. We will look on the negative electron revolving around positive nuclei. And in contrast to the previous couple of lectures, we will admit that distance between electron and nuclei may change. So it is not nailed down rigid rod connecting them, but they can keep rotating more extended and or more contracted. There are two things that we will try to cover in this month. First, did you read the Bible story about David and Goliath? So, what was the weapon of David?
Sling.
So, how does it work? What's the physical principle?
Angular momentum stretches, shoots a rock.
So, did you try to do a sling and throw a stone? It's fun. And one doesn't need to do the soft leather or rope sling. One can just take a stick, split it at the end, put a little stone, and just make a motion. So when there is a rotational motion, there is a force that drives objects at the end of this rope away. The higher the velocity, the stronger the force, right? So when if I have a ball on a rope and I rotate it around myself, there are two forces. One is just I attract it to myself with a rope, and second that it wants to drive away because it wants to continue a straightforward motion. And with my force, I make it to do a circle. And same in the hydrogen atom. There are two compensating forces. One, and there are smart words for them, centrifugal and centripetal. One Coulomb attraction drives them together, keeps them together, and another, the wish of an electron to continue a linear straightforward motion, like a free electron in space. It wants to make it, instead of circular orbital, it wants to make it straightforward. So it's kind of a force that drives it away. And if it finally moves on some circular motion, it means these two forces compensate each other. Make sense? Now, if we believe in quantum theory, or if everything is proved through the previous class, then rotation of this electron around nuclei cannot occur with arbitrary velocity, arbitrary angular momentum. According to quantum laws, it will take only discrete values. And at these discrete values of rotation, the force that drives electron away will be different. So if the amount of angular momentum is discrete, then the forces are discrete, and the radii, the distances from the center, are discrete. Make sense? So through this logical train, one will see that there are several circular orbits at which electron is allowed to reside. And if you admit this idea, basically, if you would live 110 years ago, and you would express this idea in public and defend it in your talks and papers, you would get Nobel Prize earlier than Bohr. So it looks quite crazy if we do not have quantum theory. the rotation with only discrete velocities, angular momentum, and only discrete velocity. Same like traffic science telling you have below 80 miles per hour. In this quantum world, it would be only integer multiples of 10. Like you can drive 10, 20, 30, but if you are caught traveling in between, you get cited. So it's not usual for common sense. And the achievement of Bohr was just bring these crazy ideas and follow the consequences and make correspondence to experimental observations. Okay, let's go and watch the slides. And if things will go perfectly, I hope to arrive to this slide showing that energy will be as a minus inversely proportional to angular momentum squared. And if you have orbit magnetic quantum number, it will be 1 over m squared. And if one plugs in different values in certain system of units, it will be minus 1/2, minus 1/8, minus 1/18, just by plugging different integers. And these points of energies correspond to these numbers 1, 2, 3 on this diagram. So the lines correspond to energy of the electron as function of distance, assuming that it rotates with angular momentum equals 1. Here, if it rotates quicker, the force that drives it away will be bigger, and it will rotate at different radius. The minimum of potential energy will be a different place. Therefore, the energies will be different. And I'm going to go forward and just provide some math for it. So minus rotates around plus. Velocity is increment of position vector r over time. Velocity changes as we go from one angle to another one. The absolute value of velocity is the same, but the difference is only in change of the orientation. The change of velocity, this vector, is acceleration, right? Derivative of velocity over time. And they are oriented in space, like velocity is perpendicular to radius, acceleration is perpendicular to velocity and anti-parallel to the radius. So it is directed toward the center. Velocity, like distance over velocity will be time, velocity over distance will be frequency. Right? How many revolutions per second. Now one can use complex number by considering the position as a point in complex plane. And then one can obtain the same result just by taking complex derivative. So if one does this exercise, then acceleration is minus distance and a factor with omega squared, which appears from two derivatives, right? So how do you interpret it, or what do you see on the screen? What do you think by looking on this image?
It's the deal from The Martian.
where it spins,
Mhm.
the rate to keep the gravity pretty much the same as Earth. So it's not like you're in space, but it's like you're on a celestial body with gravity.
Exactly. On the International Space Station, they have a treadmills, and they need to exercise because without it, like 2 weeks in space will destroy all muscles because lack of training. And space travelers, if they do not exercise, they just like cannot move. And if this problem is safety, if in space one has the constant analog of gravity, then it will be much more healthier and one can colonize the universe, assuming that there are strong engines to bring us there. So, rotational motion, if there is this big wheel, some people call it von Braun wheel, if the International Space Station would be like a wheel and would rotate, then people would need not to exercise there because of this force that is directed in and out compared to the radius. And there are calculations telling what should be the velocity and the radius to mimic the Earth's gravity, and it's not huge. One can do it with modern engineering. Here are some examples. So this is not a new idea, it was in one of the science fiction movies. So force is acceleration times mass. And the force that acting in the opposite direction can be computed based on the kinetic energy. So the plan is that here you express two types of energies corresponding to Coulomb and kinetic energy, then take derivative of both, and then derivative of energy is a force, and then this force needs to be balanced. So if this electron is rotating, the kinetic energy is mass velocity squared, or as we do in this rotational motion, angular momentum squared over the inertia, right? Or mass times radius squared. The attraction that connects them together is charge of one particle, charge of another particle, inversely proportional to the distance, right? And the thing that was making me very unhappy in high school, that one always needs to carry the constants. And it took me a few years to realize that there is a system of units among people who do it every day, where one can skip this constant at all. So if one tweaks system of units, one can select such system of units where this constant equals 1. And this is atomic system of units. So where mass of electron is 1, charge is 1, one constant is 1, and this Coulombic factor is 1. Of course, the unit length and unit time in the system of units will be much different from system international, from like meters or from feet. The unit length is so-called Bohr radius. So it's about half angstrom. So it's a typical distance between electron and proton in the hydrogen atom. In this system of unity, it will be 1. The length, the time unit is 1 over 42 of a femtosecond. So it's a really small unit. And it is not as comfortable if we want to like build a house and measure things. But for atomic objects, it's quite comfortable. So excellent. I think we have chances to fulfill the plans. There are 2 types of energy, kinetic and potential. So since we are in atomic units, we have proton of charge +1, electron of charge -1. The potential energy is just -1 over r. The kinetic energy, angular momentum over radius squared. Total energy is their addition, right? Kinetic plus potential. Coulomb force attract, centrifugal force will repel. It's not forces, it's yet energy. And interestingly, the energy depends on distance in different fashion. 1 over r, 1 over r squared. So they are not most of the distances they are not equal to each other, but at some distance they will be equal to each other. And another thing that centrifugal force does depend on the value of angular momentum. The quicker it rotates, the stronger is this term. So we want to find stable, stationary states. And by now we pretend that we suddenly have forgotten all quantum theory. We just have only this equation and we want to find stationary states. So at which values of angular momentum and which distances this rotation will be stable and these 2 energies will compensate each other. So I suggest that we take a derivative of the total energy and find where derivative equals 0. So derivative equals 0 means forces compensate each other. They have equal in sign, equal in absolute value, and opposite in sign. So if we slowly practice derivative of this 1 over r, we need to practice derivative of 1 over r squared and 1 over r. What happens if one takes derivative of x to the power n?
And
power increases or decreases?
decreases.
Okay, so if it is r to the power -2, it will be -3. If it was -1, it will become -2, right? And there is a constant. So we are taking this derivative and setting up them to be equal to each other, or the subtraction to be 0. So they will be equal to each other when centrifugal forces are equal to each other. And by canceling radius squared, one will obtain the connection between radius and angular momentum. So, like if you have a sling that is made of some elastic material, like rubber band, the quicker you rotate, the more rubber band is expanded. Make sense? And if the rubber expands as if the forces between all of this rubber will be analogous to Coulombic force, then this equation will work. So radius will move here will be equal to angular momentum squared over mass. So if we do know angular momentum, then we automatically know the radius. Because stable trajectory will need compensation of these two forces. So it is what we borrow from classical mechanics. Now, suddenly we can remember, oh, we were studying physical chemistry. We know quantum theory. So what are allowed values of the angular momentum?
Integers?
Integers of Planck constant. But if Planck constant is 1, then it will be just integers. Right? So we are going to plug in integers and get allowed values of radius. So radius is angular momentum squared, but angular momentum is Planck constant times this m number. So if we have the rotation with angular momentum 1, 2, 3, then the radius will be 1, 4, 9. And it will give the right to people to draw this circular orbitals, assuming that electron moves on different. Again, it is not what is actually happening, but it helps to catch some important features. Okay, so we are yet missing energy. So we, if the centrifugal and centrifugal compensate each other, radius takes these values, and now we need to actually compute the energy. At the beginning slide of this new material, I was showing potential curves and stable compensated forces correspond to minima of energy. So these solutions correspond to minimum of this potential curves, right? And we may plug in these values of allowed distances into the expression for the total energy, which is kinetic plus potential. And if we here, this dashed lines is our potential lines of total energy and the long dashes. And the solid line and thin short dashes are Coulomb attraction and centrifugal propulsion. So Coulomb attraction is always the same, and the centrifugal repulsion becomes more and more repulsive if it rotates quicker. And by adding together these short dashes and one of the color solid lines, one would get this potentials with meaning. And depending on the value of angular momentum, the minimum will be located in different points. When I was preparing these slides in previous year, when writing and drawing this figure by hand, one doesn't realize that the scale changes drastically. So if you look on even the third one, it looks almost flat. But if one expands this area, it's still a minimum. Yeah, so here it is zoomed in, and then one can see that 0.3 is in the minimum. So let's plug this values of radius into the expression for total energy. So angular momentum squared here there cancels, leaving only L squared for propulsive and attractive. And then this minus stays here, So we just have 1 over L squared goes out of brackets, and in brackets we have 1/2 minus 1. So after doing complicated algebra, subtracting these numbers, we get minus 1/2, 1 over L squared. So it is the allowed energies. The energies are expressed in units of in atomic units. There is a conversion factor from atomic units to normal and like to any units of energy. There is one that I remember from atomic units to electron volts. It is about 27 electron volts in one atomic unit. For reference point, the visible light is about 2.5 electron volts. So 27 is far beneath. Here, the minimal energy is minus 1/2, which means like minus 13.5 electron volts, which is still in the UV. But if you will look for transitions between different states, especially with larger number, their offset may come to the visible range and make hydrogen atom visible for fluids. What else? So main consequence that is kind of basic, natural, and simple for us, that energies take discrete values. But in the time when it was designed, it was very new, crazy idea. So that electron in the atom is allowed to take only certain values. But if one plugs in the certain offsets between these certain values, one is reproducing the spectrum, which I'll try to show in the remaining time. Any questions here? Any? I'm not sure. Check with. Spencer, any questions about the slide? More. Any questions? One. Any questions? Two. Any questions? Three. I think there were no questions. Whew. Any objections? See what is next. So they all are negative, right? And negative means stable. So negative energy means they are attracting, and in order to break them apart, one needs sufficient energy. Like to ionize, it should be positive energy to bring it from negative to 0 to positive. So after one completes this background of Bohr theory, which is, I'm not sure if I delivered it well, but it's in many textbooks, it seems so self-evident or boring to the author that it is skimmed through without details. But the consequences of the Bohr theory are discussed enthusiastically everywhere, in any textbook and even sometimes in high school. So one should be careful with these images like this, not to scale. They are just proof of concept images. But the idea is that depending on this rotational quantum number, there are different orbits. And again, one always should remember and declare that we do not believe in orbits. Electron is not moving on an ideal circle. There are much more exact and precise solutions which are doable, which just save time. So each of this orbital has its energy. And if the atom absorbs or emits light, it means electron is being promoted from one to another orbit. So in order to compute the frequency, wavelength of transition, one just need to subtract energies of the state. And typically one is doing Bohr conversion in different units, but we already saw in atomic units is beautiful, like -1/2. What is next? Minus 1/8.
Minus 1/18.
Yes. And then if one looks transition from the lowest one to the next possible one, there is a progression, and spectroscopists often use nanometers, which are inverse of the energy inverse frequency. And from lowest to next possible, it is far UV, right? The visible light is around 600. If one looks from the number 2 to each next, then it starts coming into the visible range. So this transition from number 2 to number 3 is visible, and the next one is also visible. And then if one goes from the 3rd higher up, it will be longer wavelengths corresponding to infrared. So these lines in spectrum were experimentally observed a long time before the theory was developed. And it was the big challenge to try to develop any theory that explain why it is so. Because people were believing that any rotation is possible, any velocity, any distance is possible, and it was a big contradiction. But the experimental experts who did observe and describe these lines, like I gave them their names. So there are like Lyman, Balmer, Fashion, and the first one here is UV. The next one, Balmer, is visible, and the next one, Fashion, is infrared. Right? So if we leave behind the potential as function of radius and accept only points of energy, there will be like number 1, number 2, number 3, and we will draw these energies as lines. Then the lowest one, minus 13.6, which is minus 0.5 in atomic units. Here is the second one, and so forth. And one can draw lines and approximately assess the energies on the energy scale. So going from anything to the lowest state will be UV. Going from basically anywhere to the second one will be visible, and then it will be infrared. And this image is to scale. So one can just measure the lengths and get the subtraction of these numbers. So basically by practicing this, tabulating these values, one can reproduce the positions of these lines. And the experiment looks like emission rather than absorption. Absorption is hard because only the lowest state is occupied. But if one makes discharge, like in luminescent lamps, then electron discharge brings electron higher up, and then it can go back through several pathways, non-radiative and emit light. And then the spectrum looks this way. Modern spectrophotometers use diffraction gratings, but obsolete things used the glass prism. Well, make this discharge, slide prism, then let's see several lines.